Good evening, friends. I had posted a Sudoku earlier in the morning today, which was a hybrid of sandwich and arrow Sudoku. And I believe I've got quite a few requests as to how to go about it because they have not been able to solve it. They have stopped in between somewhere. So I think it is best that I don't pick it up from where they have left it, but I shall do it right from the beginning so as to give you a hang of as to how to do sandwich or arrow Sudokus. Now in this sandwich Sudokus, as I said that 0 would be between 1 and 9, there would be no space. 33 would be the sum of the digits between 1 and 9. Likewise 20, 27, 13, 13, 20. And these arrows, at the tip of the arrow, the number is the minimum, the least, and it keeps on increasing. So let's see how to go about it. Now 33 is a very big clue. The sum of the total from 1 to 9 is 45, and it has to be sandwiched between 1 and 9. So 45 minus 1 and 9 is 10, which is 35. So the only digit which remains between outside of 1 and 9 is 2. So either the 2 is here or the 2 is here. Now I don't want to put 1 and 9 here, 1 and 9 here, because I don't know whether the 1 because 1 and 9 here, because the 1 and 9 could be here or it could be here. You know, the 1 could be here, 9 could be here, and 2 could be here, or it could be 1 here, 9 here, and 2 here. So there's no point putting that. So I've just put 2 digits on the outer cells because those are the ones, because 33 plus 10 is 43 and 2 is 45. Now let's see, these digits keep on increasing. So either it is 1, 2, 5 or 1, 2, 6, or if it's 1, 2, 6, this is going to be a 9, and if it's it could be 2, 3, 4, which could be a 9. So this digit cannot be less than 6. So this circle has to be 6, 7, 8 or 9. So you'll remember this: 6, 7, 8 or 9. Now the best part here is that this digit is very, very important here. I'll tell you why. If either of these two is a 9, then this won't be a 9. Neither would this be a 9, because it's in the same box. Now, one of the reasons why we have to assume that way is that this particular tip of the arrow can be either a 1 or a 2. Now 6, 7 and 8 cannot begin with a 2. If you see, 6, 7 and 8 can only have, if you begin with a 2, it will be 2, 3, 4, which will again be a 9, and it has to be in an increasing order. So obviously, and it cannot be 2, 4 and 5, because that goes, the sum total of that digit goes beyond 9. So this has to be a 1. Now if this is a 1, this digit cannot be a 1. So this has to be the minimum, most minimum has to be a 2. So this digit is forced to be a 2. Now I'm not pushing it here, but I will remember this in my mind, that this digit is to be either 1 or 2, or 1 or 2, because we have said it could be either 6, 7 and 8 can begin with a 2, 9 has to begin with a 1. So this is something which we have to remember. Now automatically, if this is a 1 or 2 or 1 or 2, then this cannot be a 2, so this will be a 2. Because either of this is a 2, so there cannot be a 2 here. Now, if this is a 1, this cannot be a 1 here, so this has to be a 9, and this has to be a 1, because you remember that 1 plus 9 is 10, plus 2 is 12, and the remaining is 33, which is 45. So this is the way you have to derive this digit. Now, one of the things that you will immediately see is 1, 2 cannot come here. This is 6, 7, 8 or 9. So this becomes a 1, 2 pair. So we'll remember this pair. It is 1, 2. That's the reason why I've written it. Now, this being a 2, because this is a 2, automatically I know that this is a 1. And automatically, because this is a 1, there cannot be a 9 here. So my assumption that this could be a 9 or this could be a 9 is correct. So this cannot be a 9. And if this cannot be a 9, obviously this won't be a 9 either, because this is a 9 again here. Now this is a 1. So this is bound to be a 2, because we had said either this is a 1 or a 2. And this being a 2, this is bound to be a 1. Now, this 2 automatically gives us a digit. It has to be in an increasing order. 2 plus 3, 4 is equal to 9. Now this 9 and this 9 interact to give us a 9 here. This 3, either of these 3 could be a 9. If this is a 1, this is a 3, then there cannot be a 4 here. 1 plus 4 is 5 and 5 is 10. So this has to be a 2. And this has to be a 3 or a 5. And if this is a 3 or a 5, this digit cannot be a 7. Because the total of 1 plus 2 plus 3 is 6 and the total of 1 plus 2 plus 5 is 8. So this is to be a 6 or an 8. Now let's see here. This being a 3, again this puts it at 2. So again this is a 3 or a 5. So again this is a 6 or an 8. So if this is a 6 or an 8, it cannot be a 9, obviously 6 or an 8, and this cannot be a 6 or an 8. So this has to be a 7 because this is already a 9 here. Now if this is a 7, this being a 2 and a 1, this has to be a 3 because that is the tip of the arrow is the smallest, and this has to be a 4. Now this 1, 1 and 1 by normal Sudokus makes it 1 here. Now this 1 and 1 interact here and make this as 1 here and 1 here. This 2 pushes the 2 here. 2 makes it a 1 and 2 pair. So far what we are doing is, so far we are solving the circles in the grid. Now 7 and 9, 6 and 8. Okay. Now one of the things that you have to realize is that this is a 9, there cannot be a 1 here because between 1 and 9 there cannot be 13. 13 is at least 2 digits. So if this is a 9, this has to be a 1, but it cannot be a 1 because of this. Now if this is a 9, there cannot be a 1 here or here because of these two ones. So this is forced to be 1, and if this is forced to be 1, this is 2, and if this is forced to be 2, then this again will be 2 because 2, this cannot be a 2 because of 1, 2. This cannot be a 2 because of this 2. So this is a 2. Now if between 1 and 9, if this is one of the things that we must realize is that this is a 6 or an 8, 6 or an 8, and 1, 2. So 1, 2, 6, 7, 8, 9 is taken care of. So this is 3, 4, and 5. Okay. So this being a 3, 4, 5, this has to be an 8 and a 5 because that's the only digit that these are the two digits that total to 13. So if this is an 8, this is a 5, and if this is an 8, this is a 6. Now if this is an 8, this totals to 5 because 1, 2, 3 plus 5 is 8. 1 plus 2 plus 3 equals 6. Now if this is 1 plus 2 plus 3 equals 6, which we've already got. Now if this is 5 here, this automatically becomes a 3, 4 pair. So this is a 3, 4 pair. And if this is a 3, 4 and 5 here, so this is automatically a 6, 7 and 8 triple. Okay. Now, having said that, let us look at what else can we get. Now this 3 and 3 make this either a 3 or a 3. Now, one of the most important things that which we can figure out here from this is that this one and this one interact to give us these two as ones. Obviously, this being a 0, this has to be a 1 or a 9. The reason is because 1 and 9 is already here, so I cannot place 1 or 9 here. I cannot have a 1 here. If I have a 1 here, then I have to have a 9 here or a 9 here, which I cannot do. I cannot put a 1 anywhere here because of these two ones. I cannot put a 1 here, so this is bound to be a 1. So this is bound to be a 9. So we've got 9, 9. Now these two 9s will interact with each other. Now, one of the important things that we have to figure out here is 6 plus 7, 13 plus 2, 15. Now 15 plus 12 is 27. There cannot be ever a 12. There has to be a 12 has to be divided between two digits. So obviously 9 cannot come here. 9 has to come here because there has to be a sandwich. Now what are the digits that total to 12? 6 and 7, 13 plus 2, 15 and 12, 27. 4, 3 or a 4. So 3 and 9 can total to 12. There cannot be a 9 again here. So this is bound to be a 4 and this is bound to be an 8 and this is bound to be a 3 because we had said that this is a 3, 4 pair. This 3 and this 3 interact to give us this 3. This 3, 3, this 3 comes here. So we fixed that 3. Now this is 4, 6 and 7. So we'll write that as 4, 6 and 7 here, because those are the digits that are remaining. Now this is 3 and 5 here, which is remaining. So 3, 3, 3 and 5. So we've got that part. Now the thing which we have to look at this out here is that we have solved pretty much all the sandwiches except this particular sandwich and this sandwich. So let's solve this sandwich. This 9 is here, so the 9 can be only here. Now if there is a 9 here, let's take this digit. 7 plus 8, 15 plus 1, 16 and 4. 4 cannot come here, so this 1 cannot come. Let's work out a 2. Can we have a 2 here? 7 plus 8, 15 plus 2, 17 and 3. 3 cannot come here, so this is 20. So if this is a 9 here, and if there is a 1 placed here somewhere, 20 cannot be 5 digits long. 20 cannot be 5 digits long, so the 9 is to be either here or here. Now with the 9 here, we saw that it doesn't work out, so the 9 is bound to be here. Now how does it work? 7 plus 1, 8 plus 8, 16 and 4 cannot be possible. So there is a 3 possible here. So this is a 2 and this is a 1. Now this 9 puts a sandwich of 20 in between. 7 plus 2, 9 plus 8, 17 and 3, 20. So that's taken care of that. Now there is a 4, 5 and a 6 pair which is remaining here. So let's do that. 4, 5. Now this 3 pushes a 3 here, because we had said that there was either a 3 here or here. So this is a 4, 5 and 6 pair. Sorry, triple. 4, 5 and 6, triple. Now, having said that, 467. Now, one of the other sandwiches which is remaining is this sandwich. Now, between 9 and 1, we've already got the digits 9 and 1. So, what are the permutations for 17 apart from the 3 which we've got? 17 in 3 digits would be 4, 5 and 8 maybe. So 5 could come here, but 4 would come here and then 8 would come here. So that is a possibility, and then this would be 6 and 7, because 20 plus 10 is 30. 20 plus 20 plus 10 is 30, 32. So this is 13. 13 is what? 5, 6, 7 and 8. So this is either a 5, 8 pair or a 6, 7 pair, because that's the remaining digit which remains. So we'll come to that, because we are not able to fix that yet. Now let's see what else we can fix. Can we do something with a 4? Yeah, we can do something with a 4. 4, 4. So this is a 4 or a 4 here. 9, 9. So this is a 4, 9 pair. Now if this is a 4 and a 9 pair, let's see. So this is 5, 6, 7 and 8 pair. So 5, 6, 7, 8, 5, 6, 7, 8, 6, 7, 8, 6, 7, 8. So 6, 7, 8. Sorry, this again will be a 5, 6, 7, 8, because this 5 is looking at this. So this is 5, 6, 7, 8, 5, 6, 7, 8, 5, 6, 7, 8. Now, in this, yeah, one of the things that we just noticed is that this 5 and this 5 interact together to give us these two as 5s and this 5. Now, one of the things, yeah, let's fix this 13. How do you fix this 13? This 13 is also a sandwich, which is important. So that will resolve. 9 and 1 is 10. So the only way is 4 and 6. So there cannot be a 5. It has to be a 4 and a 6. 4 and 6. There cannot be a 5 at all, because if there is a 5 plus 3, 8, and then you need another 5. So 4 and 6. So which is 5, 7, 8 here. 5, 7, 8 here, 7, 8, because this is a 5 here. So 4 and 6 is something which needs to be fixed here. Now, if there cannot be a 5 here with this 5, so there cannot be a 5 here at all, because if I had to put a 5 here, then there would be a 5 here, which is not possible because of 4, 6. We just resolved that. So if this being a 4, 6, this is a 4, 5, 6, as we said. Now this being a 4, 5, 6, 5, 5, so there can be only a 5 here or here. So if this is either of these two could be a 5. Now let's take a look at it. Four and a 9. Now, where can we fix a 9? Is there another clue that gives us to fix a 9? 4, 20 is fixed. 20 plus 10 is 30. So 30 and 4, 5 and 6 here. So that gives us 5, 7 and 8. Now 2, 4, 5, 7, 8 is possible here. So 2 and 4 is here. So 5, 7 and 8 is possible. Now that being said, 5, 7 and 8. This is 6, 7 and 8. 5, 7 and 8. This is 6, 7 and 8. So 6, 7, 8, 6, 7, 8 and 5, 7, 8 comes here and 5, 7, 8 comes here. Now the other thing that we had said, yes, see, this is an important thing. 2, 2, 2, 2, normal Sudoku rules. This 2 comes here. So this is 5, 7, 8. 4, 5, 7, 8 comes here. And we had said, sorry, there cannot be a 5, because we had just said if there is a 5 either, there won't be a 5. There has to be a 5 here, and 5 cannot come here. This is 7 and 8. This is a 4, 7, 8 pair. So look, this is good. 6, 7, 8, 7, 8, 6, 7, 8. So this is a triple. So this forces a 5 to be here. I hope you understood that. 7, 8 is here, 6, 7, 8 is here, and 6, 7, 8 is here. So by itself, these 3 will gobble up the 3 cells. So this leaves a 5 here. So there'll be a 5 here. Now, what does it give? Where can we fix a 9? I'm still looking at a possibility of a 9. This is a 4, 6. So 4, 5, 6 is there. 6, 7, and 8, 6, 7, and 8. And let me fix up a 1 here, because 1, 1 and 1 comes here. 1, 1 and 1 comes here. Now where can the 9 go in this row? 9 cannot come here. 9 cannot come here. 9 cannot come here. So the 9 will come here, and this was a 4, 9 pair. Now that being a 4, 9 pair, the 4 could be either here or here. So we don't know which is what. Now this 4 fixes the 4 here, because 4, 4 was there. Now 5, 6 is remaining. There could be a 5 here, or there could be a 5. There cannot be a 5 here, because we had just said, so the 5 is forced to be here, and this is a 6, because there was a 4, 6 pair, and this is a 6, this is a 4. And if this is a 4, this is a 4. And if this is a 4, 4, this fixes a 4 here. And if this 4, 4 is already there. Now 5, 7 and 8 fixes here. So if 5 is here, 7, 8 is, we don't know what is what. 6, 7 and 8. So 5, 6, 7, 8 remains. Now the thing which remains here is now 6, 1, 9, 2, 3. 4 and 5 is already here. So the 4 and 5 have to fix here. So this is a 4 and this is a 5 because of this 5. Now 7 and 8 fixes here. Because 7 and 8 fixes here, this automatically becomes a 6. Now because this automatically becomes a 6, 6, 6, 6 is already fixed. So now this is 7, 8. We don't know which is what. This is 7, 8. We don't know which is what. So 7, 8, 5, 6, 9 is remaining. So the 5 is already taken up by this. So this becomes a 5. 6 and 9 remain here. Because of 6 and 9 remaining here, 6 automatically comes here because the 6 comes. 6 is here. Now this is a 7 and an 8. This 8 is already there. So this is 8 is there, and this 7. Now this 8 interacts. 8, 8, 8 is already there. We don't know. Now this being a 7, this being a 4, this is already a 6, which is a good thing. So what happens is now 5, 7 and 9 remains in this. 9 is here, 9 is here, so the 9 comes here. Now 9, 9, make it a 9 here. This is a 6 automatically, which is the remaining digit. 7 and 8 comes here, 7 and 8 comes here, 7 and 8 comes here, 7 and 8 comes here. So 7 and 8 comes here, 7 and 8 comes here. So now this is 6, 7 and 8, 5, 6, 7 and 8. Now let's try to see if we can finish this. 57 needs to be fixed. So this is a 5, this is a 7, this is a 7 automatically, 7, 7. There can be a 7 in either of these squares, so we don't know which is what. So this is 568 is remaining. 5 cannot come here because of this 5. 5 cannot come here because of this 5. So the 5 comes here. 6 and 8 is remaining. So 6 and 8 comes here. We don't know which is what. Now this is 689, which is remaining. 689, right? So this 9 and this 9 interact to give us a 9 here to fix up that digit. So 6 and 8 remains to come here. 6 and 8 remains to come here. Now 6, 7 and 8 is remaining. Now look at this. This is 7 and 8. One of the things in a Sudoku that you must remember is that if this is a 7 and 8 here, and this is a 7 and an 8 here, this is also a 7 and an 8 here, we don't know, and this could be a 6, 7 and 8 because we don't know, and this is a 6, 8 pair, and this is a 6, 8 pair, and this is a 6, 8 pair, right? Now, if you look at this 7, 8 and this 7, 8, which is common here, what is the uncommon digit, which is 6? If I were to put a 7 here, this would be an 8, and this would be a 7, and this would be a 6. If I were to put an 8 here, this would be a 7, this would be an 8, and then again this would be a 7, and this would be a 6. But normally, and then this could be an 8, and then this could be a 6. But what happens is that there is a simple mathematical solution to this. What we normally do in a Sudoku is, let me just put this brightly, 7, 8 here. When there is a 7, 8, 7, 8 like this, and 7, 8, 7, 8, and an extra digit like this, we blindly put this extra digit here in a Sudoku, because whatever way you work, this will be the correct way to do it. If you try to analyze this further, automatically, which I suggest that you do it after the video, then try to see it that whether 6 comes here and it fixes the solution. Now see, if this 6 is here, this is 8, this is a 6. If this is a 6, this is an 8. If this is an 8, then this automatically becomes an 8, 8, 8, 8. This becomes a 7, 7, 7. This cannot be a 7, so this is bound to be a 7. This is a 7 here. If this is a 7, this is an 8. If this is a 6, this is a 7. If this is a 7, it's already this digit has been filled. This is a 6, this is an 8. This is an 8, this is a 7. This is an 8, and this is a 7. So we are done with this Sudoku, right? So if you check everything, it will all fit perfectly. 1 plus 2 plus 5 is 8. 2 plus 3 plus 4 is 9. 1 plus 2 plus 3 is 6. 3 plus 4 is 7. Between sandwich the two digits total to 27 or a 13 or a 13 or a 20 or a 20 or a 33 or 0, which is 1 and 9. So we finish the Sudoku, and all the rows, columns and boxes are digits 1 to 9 without repetition. I hope you enjoyed it, and if you have any questions, let me know.